All right. I'll be taking radioactivity now, and during the course of this, we're going to be discussing the band of stability. Radioactivity is actually a spontaneous disintegration of an unstable nuclei to emit radiation. So, which means if a nuclei emits radiation, we say that it is undergoing radioactivity. Okay. Now, a nuclei can only emit radiation when the nuclei is unstable. Now, when is a nuclei said to be unstable? A nuclei is said to be unstable when the number of neutron to proton ratio is not equal to 1. So at that instance, you say that the nuclei is unstable. Now, if you look at carbon 12, carbon 13, carbon 14, they are all isotopes of carbon. But the most stable is carbon 12. Why is carbon 12 most stable? It's stable because if you take the number of proton, which you can calculate by saying mass number minus number of protons. What's our mass number? There 12. What's our number of protons? There's 6. When you say 12 minus 6, that will give you 6. So that's the number of neutrons. So if you say neutron to proton ratio, that is 6 over 6 will give you 1. So carbon 12 is stable. Okay. Now, going over to the other one, carbon 14. Carbon 14 has number of protons, 6 number of neutrons. We are going to calculate by saying 14 minus 6, and that gives us 8. So 8 all over 6 will be giving us around 1.3. So this is unstable. So if I want to represent this in ratio form, I will simply say that this is 1:1. And if I want to represent this in a ratio form, I will say that this is 1:3. Sorry, 1.3:1. So which means this one here stands for number of neutrons, stands for number of protons. Why this one here stands for number of neutrons, this one here stands for number of protons. So when the number of neutron to the number of proton is 1:1, that atom is said to be stable. But once there is a deviation from 1 to maybe 1.3 or less, then that substance is said to be unstable. Hence, um, radioactivity will take place. Now, when we talk about band of stability, what are we talking about? The band of stability is simply a graph that shows us um, the a graph that shows us the relationship between neutron and proton of against protons, and then we discovered that there is a very straight line, this one running very straight, that's the proportional line. You can see that it's a direct proportion, 20 to 20, 40 to 40, 60 to 60, 80 to 80, and each time 80 over 80 to give you 1. So this straight line is called the stability belt. Then if you look at the green line is actually a deviation from the straight line. We're going to illustrate that.